Hello friends, I am Ravi Bhutani. I am working as assistant professor in Marwadi Education Foundation, Faculty of Engineering, Rajkot, in Department of Electronics and Communication Engineering. For Texas Instrument India organized TI MCU Design Contest 2012. My project title is Low Cost Fault Location Finding System for MV Electrical Power Distribution Network. The target market of this project is government sector and private sector electrical power distribution companies as well as electrical power transmission companies. I am really thankful to Texas Instrument India for providing me opportunity to participate in this contest and providing me support while designing a system. There are basically three key points which makes my system different from the systems available in the market. The first point is the system is very low cost because I have used Texas Instrument value line microcontroller and operational amplifier. The second key point, operating life of the system is very long because I have utilized the low power mode of the Texas Instrument microcontrollers very efficiently in my system. And the third key point is the system is very reliable because I have used a 16-bit microcontroller MSP430 G2553 in my system.
So let's see the working principle of the system. Now first we see how the system behaves in absence of the fault sensors. So when fault sensors are not located in the feeder system, suppose the fault occurs at this section of the feeder, then service personnel randomly open and close the different switch gears in the feeder system to localize the fault. It will create unnecessary stress and wear on a very costly switch gears of the system, and to localize the fault it will take several hours, and in a large feeder network it will sometime require more time to localize the fault. So here when the fault sensor are installed on the network, this is the typical installation of the fault sensors. Generally the fault sensors are located at the section of the feeder like this. So suppose the fault occurs here, so there is a high fault current which is passed through this path, and whatever the sensors through which the fault current passes, they are start blinking, and it will blink up to 2 hours, 4 hours or 6 hours, that is depend upon the setting on the sensor.
So let's see the demonstration of the fault sensor. This is inductive current sensor which is placed nearer to MV overhead line, and it senses the alternating magnetic field produced by current flowing through MV overhead line. So it is basically measures the current flowing in MV overhead line. The output of this inductive current sensor is fed to the input of this sensor board, which is designed around MSP430 2553 ultra low power value line 16-bit microcontroller provided by Texas Instrument, and the signal conditioning circuitry is designed around OPA 2379 ultra low power dual op amp and TLV 3402 ultra low power comparator. Here I have used the launchpad to provide the power supply of 3.3 volt to this circuitry. Actually when the circuit is in full phase operation, the power supply is provided by 3.6 volt lithium cell. Here I have used oscilloscope cum function generator to observe the waveform and generate a test signal. The function generator generates a 15 Hz sine wave which is used to test the circuit. This sine wave simulates the behavior of output of the inductive current sensor. So I have applied this sine wave at input of the fault sensor circuit. The green signal is a sine wave which is provided by function generator, and yellow signal is the output of the comparator which is used as a zero crossing detector. The rising edge and falling edge of the square wave is used as an interrupt by microcontroller to wake up the microcontroller after predefined time period, so microcontroller will remain in a sleep mode most of the time. Here the input voltage is shifted at a level of VCC by 2, and then it is measured by ADC of the microcontroller. Here you can see after rising edge the timer of microcontroller is set at 5 millisecond, and after 5 millisecond it will get the sample. So microcontroller is in active mode only a duration of 65 microsecond, and it will remain in sleep mode most of the time per cycle. So when the input voltage is more than the threshold value, then this LED will start blinking. So I am going to increase the input voltage. So now the LED start blinking and it shows the arrival of fault. So once the fault is seen by the service personnel, using the magnet, service personnel can easily reset the microcontroller using the reed switch. So circuit has few capabilities like sense the Imax, sense the rate of change of current Dimax, and it detects the fault based on Imax and Dimax, and the setting of Imax and Dimax can be easily done by switches provided on the board.